All right. Are we ready? Okay. So for the next 2 days, we are studying special right triangles. At the top of the notes, so you can differentiate between these and the next set of notes we're going to do more easily, we're just going to write 30, 60, 90 really big. 30, 60, 90. So today, the special right triangle that we're looking at is a 30, 60, 90 triangle. They have a specific ratio between the side lengths that we will notice as we get going here. So 30, 60, 90 is what we're looking at today. Tomorrow is going to be 45, 45, 90. So we want to be able to get to look back and forth between these two notes really easily. So if we are looking at this first triangle, we've got a side that's 5, a side length that's 10, the hypotenuse is 10. And we want to find the third side. It's a right triangle. How do we find the third side? Yeah, Pythagorean Theorem. So I'm going to say, what should we label the third side? X? Okay. So what should I do? Okay. Oh, not plus, equals. So we've got 100 equals 25 plus x squared. And then how do I want to solve for x? Okay, so I'll minus the 25, which gives me 75. And then what do I do? Square root. And how many answers do I have? 2. X equals plus or minus 75, square root 75. But the actual answer we're going to use is the positive version, not the negative version. And is square root 75 a proper answer for that side? No, we can reduce it. Do you guys want to look for the perfect square in there, or do you want to use a factor tree? Perfect square? Okay. So what perfect square is in 75? Nope, we're not going to do that. We're going to leave it in simplified radical form. I'm so sorry. No, I think the homework set, well, depending on the instructions, these instructions are vague, they didn't tell you. But depending on the instructions, if the instructions say reduce the radical or simplified radical form, then you leave it as a radical. If the instructions tell you to round, and I think the instructions on the assignment before, depending on the problem, I think they went back and forth. So it depends on the last assignment. All right, so if we were to reduce this radical, what's the perfect square that's in 75? 25. So we got root 25 times root 3. So that's 5 root 3. So this missing side is 5 root 3. So the sides are 5 root 3, and 10. Okay, let's do the same thing for the other triangle. So I'm going to label the missing side as an X. And when I do the Pythagorean Theorem, what should I be writing? Okay. So 16 plus x squared equals 64. So our answer is going to be the positive version. And then we want to reduce that radical. So what's the perfect square that goes into 48? Okay, so x equals square root of 16 times the square root of what? 3. X equals 4 root 3. Okay. What do you guys notice is in common between these two triangles? So the angles are the same, 30, 60, 90. And then what about the side lengths? What's one half of each other? Okay. So let's be more specific. Which sides are one half? The hypotenuse. So we've got the shortest side, and then the hypotenuse is twice as long as the shortest side. Okay. Peter, what are you noticing? Okay. So the shorter leg times root 3 is the longer leg. Okay, so let's write down what we noticed. So we've got, this is the 60-degree angle, this is the 30-degree angle, here's the 90-degree angle. So if I wrote that A, this is the shorter leg, A is the shorter leg, then what would the hypotenuse be? 2A, okay. And then what would the longer leg be? A root 3. Okay, so that is the relationship between the three sides of a 30, 60, 90 triangle. Always. They always have that relationship. A, 2A, and A root 3. Always. Okay. Now, the people who made these notes, they said to use similar triangles to solve it, and you can, but I didn't learn it that way, and I don't think that we necessarily need to do it that way. So let's go ahead and solve this problem. I think that you guys can do it probably without having similar triangles. So let's label 60, 30, 90. And let's say that this side is 5. And hold on. Did you guys start drawing already? Okay, I'm gonna purposefully draw this picture not to scale. So do you guys see how I drew this so you can't tell which leg is which? You guys see that? Okay. So I'm purposefully drawing this badly. Okay. So I'm gonna say that this side is, somebody give me a number. Number other than 5 and 4, because we already used those. 6. Okay. So I'm going to say that that side is 6. Can you guys tell which side, based on the angle measurements, can you tell which side I put in there? I put in the short side. How do you know it's the short side? Yeah, so don't do it based on how it looks, because then you're depending on somebody doing an accurate drawing. Does that make sense? We don't want to do it based on somebody doing an accurate drawing, okay? So I know this is the short side because it's across from the 30-degree angle. Does that make sense? Okay, so that's how I know it's the short side. So let's figure out what the other two sides are based on that, okay? So what should this side be? 12, okay, 12. So we just do 2 times that. And then what should this side be? 6 root 3. You guys see how that works? Okay. All right. Now let's go ahead and, you guys ready for one that's a little bit strange? No, let's do an easy one before we do a strange one. Another easy one. I'm gonna set it up. I'm gonna draw all of them so that you can't tell what the short side is, okay? So okay. So somebody tell me, what is x? X equals 9. Okay, so y equals 9 root 3. Okay. Okay. All right. What is x? 2. What is y? 4. Okay. So when they have the sides being what they should be predictably, when the sides are acting right, these triangles are really easy to fill in. Does that make sense? When the little side is acting like the little side, it's easy. When the side across from the 60-degree side, when the long leg is acting like the long leg, it's really easy. Okay? So I'm going to give you one that's not going to act right. Okay? I'm going to give you one that is acting incorrectly. Are you guys ready? You guys are like, no, don't do it, Miss Reich. Okay, somebody give me a number. 8. Okay. What's wrong with this problem?
The other side looks shorter.
What's wrong? So I drew it not to scale, so that's wrong. Peter, what's wrong with this problem? It's on the root 3 side. You guys see that? The 8 is on the wrong side. It's acting incorrectly. Does that make sense? So that means that these sides are going to all look wrong. We cannot use the shortcuts. Does that make sense? Okay, so what I'm going to do is I'm going to draw another triangle over here with the 60 and the 30, and I'm going to label the sides 2a, a root 3, and a. Okay? And I'm going to say the 8 is on the a root 3 side. So 8 equals a root 3. Does that make sense? My goal is to figure out what the a is. For the other problems, because the sides were acting the way we expected them to act, we could figure out a without hardly using our brains. We could figure it out, we could plug it in, we could use it because the sides were acting the way we expected. So we looked here and we were like, oh, 18 is 2a, I hardly have to use my brain to do that. A equals 9, 9a, or 9 root 3. So we figured out a without even really realizing that we knew what a was. Does that make sense? Over here, it was 2 root 3, so we said, oh, a is 2. A is 2, 2a, 4. So when the a was acting predictably, we hardly even had to think before we did the problem. Over here, a is not being predictable, so we're going to have to think pretty hard for us to do this problem. Does that make sense? So now we have to figure out what the a is. It's not going to be a nice number. It's not going to be a nice whole number. It's going to be messy. Okay? So the other two sides are going to be messy. We're going to solve it like an equation. So let's write x and y so we know what we're doing. So go ahead and write x and y. All right, so how do I solve for a? You don't square both sides because it's a times root 3. Divide by root 3. So we have 8 over root 3 is a, but what do we know about having radicals on the bottom? It's not acceptable, right? So what do? Multiply by root 3 over like top and bottom, right? What's that process called? It starts with an R. Not reciprocal. RA. Rationalize. It's called rationalizing. Okay, so now I'm going to take the 8 over root 3 and I'm going to multiply by root 3 over root 3. You guys remember that? It's been a minute since we've done it, but we've done it before. Okay, so on the top, what do we get? So we get 8 root 3 on the top. What do we get on the bottom? Root 9, what's root 9? 3. Okay, so our A value is 8 root 3 over 3. Okay, so which side is just A? The y. Okay, so this side is 8 root 3 over 3. Done. Okay, now the x side is 2 times this.
So couldn't you just do 2 over 1 times?
So 2a is going to be 2 times 8 root 3 over 3. And so what do I get when I do 2 times that? 16. Yeah, 16 root 3 over 3. So 2a is 16 root 3 over 3. Okay. Yes, Peter. You cannot use decimals because that is you're getting the right answer, but when you're doing it, you're kind of using the lazy way out. Does that make sense? Now, when we do 30, 60, 90 triangles, the benefit of this is that you could do this without a calculator, and you can do this anytime you know you have a 30, 60, 90 triangle. That means you only have to know one side. You can solve for the 2 others. Does that make sense? So if somebody says, hey, you have an equilateral triangle, you automatically know with an equilateral triangle, you've got 60 degrees, 60 degrees, 60 degrees, right? And if somebody says, hey, find the area of that triangle, you can split this down the middle, and then what happens? What happens if you split that down the middle? You've got 2 30, 60, 90 triangles. So if you have one measurement there, you've got everything. Does that make sense? But you only have those measurements if you have exact numbers for those measurements. Does that make sense? If somebody took your calculator away, which is pretty common for those of you guys who are going to stay on the honors track, for you to not have calculators in the future. So if I let you guys do this without calculators now, I'm only setting you up for failure in the future. Does that make sense? These computations are annoying, but they're not difficult if we practice them. Does that make sense? There's a difference between tedious and difficult. These are tedious, but they're not hard. Does that make sense? We've done them. You guys did well on the test where we did this. The test scores were good. So it's not that we can't do them, it's that they're annoying. Does that make sense? Okay. So that's where this comes into play. Yeah. If you check the schedule, and now we're off by 1 day, basically. Whatever our schedule is, we're off by 1 day, but I'll fix it as soon as I can. Okay. How do you guys feel about that example problem? Solving for A, we can do it? Okay. So let's go to the next page. All right.
Oh, look. Look how fast that is. That's awesome. Okay, Alex. No, you won't. Actually, that's pretty bad. Are we doing this?
Yeah, so they said, we basically just, I don't know that it's a shortcut though. I don't know if I agree with these notes.
We just cross it out. I vote cross it out. Like aggressively scribble.
Will that make you feel satisfied?
Yes.
Yeah, feel free to aggressively, just scribble this part out. Do you feel better? Don't scribble the whole page.
Not example 7.
No, because I feel like it would probably be beneficial for us to do maybe another one of these. It's bothering me that that triangle looked bad. All right. This time. All right. Somebody give me some ideas. What should we do first?
X is y is equal to 22. Because the 30 is across from the x. The x is the one that has the root 3 and then the other. Right?
No, Jack. No. Wait, yeah, no, he's right. He's right.
Am I?
No, he's not. No, he's not. Y is the root 3 one, and the one across from x is a, and y is 2a.
So I gave you guys another tricky one, just like the one we just did. So what do we need to do? Okay, 11 equals a root 3. And then what do we need to do?
The root is across. No, the normal one, the short one is across. Oh no, something's across.
All right, and then how do we fix this so it's proper? So a equals, okay, so what does this tell us now?
It tells us that that's x.
This is x. Okay. So if a is 11 root 3 over 3, then how does that help us find y? Multiply by 2. So 2a is 2 times 11 root 3 over 3. Okay.
Will it ever happen that the number by the square root is divisible by 3, and then you can divide the 3
Yeah. Yeah, it's possible you could reduce it. Okay. Let's do another one. Now, this one's kind of crazy. You guys ready for a crazy one? Can we get a what in here?
How are we getting logo in here?
Crazy. Because this is math class, it can't always stay easy. All right, so this one, we're going to have x and y, and then this one is going to be 4 root 15. What?
Are you able to
Say what?
Are you able to do this method on the ones that you can you, is this applicable to all the 30, 60, 90?
This works on every single 30, 60, 90 triangle. Every single one. It works on every single 30, 60, 90 triangle.
So now you just solve it and say, wait, 15 is, I'm kidding. Yeah.
So, this is interesting. This is a weird one. What is happening here?
Well, it's on the wrong thing to begin with. Wait, I'm kidding.
So it's like on the side we want it to be, but it's the wrong root. Okay, so what are we going to do with the 4 root 15? We're still going to set it equal to a root 3. Okay, so let's do that. So we're going to say 4 root 15 equals a root 3. We're just going to see what happens. So this one's a little bit unpredictable because we haven't done one of these yet. It's a root which we might like. We're not sure. We might like it. It might be helpful that it's got a root in it, but we don't know. So what should we do? Divide by root 3. Okay, so a equals, and then what happens when you divide a root by a root? Wait, what happens? Can those divide? Okay, so what do we get? We get 4 root 5. Okay. That's allowed. Wait, what side is this? Y. Okay, so Y is... Why?
I thought 4 root 15 would be A. If you draw a little other triangle that has a coordinated.
So 4 root 15 is across from 60.
Oh wait, I thought you said it was.
I'm so good. Wait.
I said it was across from 30.
No, I drew it across from 60, so it's across from 60.
So why is the bit?
So Y is across from what angle? So Y must be across from 30, and so Y is then A. Okay, so Y, if Y is across from 30, then it's the A side, so this is 4 root 5. You gotta go flip the page and look back at the original. Okay, which side is the 2A side?
X.
The hypotenuse. Okay, so now we're gonna say 2A is 2 times 4 root 5. So 2A is 8 root 5. Okay, so that one was kind of nice. Even though it looked kind of crazy, it ended up being okay. Yeah, Peter. If I have answer keys posted, all of this should be shown. On the other page, I said this. Across from 30 is A. So the short leg is A. The long leg is A root 3. And the hypotenuse is 2A. Does that help if I write it like that? Short leg is A, long leg is A root 3, hypotenuse is 2A. Short leg, long leg, hypotenuse.
And then the short leg will always be across from the 3.
Uh-huh.
And then the long leg will be across from 60.
Uh-huh.
Thank you.
You're welcome.
That's what I needed.
Okay. So 30, 60, 90, short leg, long leg, hypotenuse. Okay. How are your brains? Brains are okay? Brains are good? Okay, we're gonna make it crazy.
Take it up and down. What if it's more? I know.
Whoa! 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 Okay, you guys. Things about to get crazy. What? Miss Rice, what? Say what? 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 Okay. Let me zoom in. Let me zoom. Okay. The triangle on the right is not bad. Why is the triangle on the right not bad? It's acting the way we would expect it to act, right? Okay. Let's put in the 30 degrees because that just makes our life easier. So, did everyone have time to draw the drawing? Yes? Okay. So, 30 degrees. 30 degrees. Okay, so the 5 is nice because it's across from the smaller side of the triangle on the right. So it's in a good spot. We like it. It's nice right there. Okay, so I don't need to find it, but I'm just going to write it here because it's going to make me happy. This hypotenuse is 10. Whew, that's satisfying. Okay, and y is also going to be pretty satisfying. It's easy to find. What is y? Okay, so it's 5 root 3. And that is exactly where the satisfying stops. No, that's satisfying, but that's where the satisfying stops.
Well, no, but the y for the other one is also 5 root 3. So then, but that's supposed to be a 2a.
But that's the hypotenuse of the other one. That's why it stops there. Okay, so it's 5 root 3 on the other one, but it's the hypotenuse of the other one. So it's 5 root 3, but it equals what side? It equals the 2a side. Ugh, why must you guys do this to us? For shame. I didn't make up this problem. These are not my notes. My notes would have a Bitmoji on it. It had my face on it, so you'd know it was mine. Alright, so what do we do? Divide by 2. Okay, so a equals 5 root 3 divided by 2. Okay, so that wasn't the worst thing that's ever happened to us. Okay, so if a is 5 root 3 over 2, then what variable is that? W. Okay, so W is right across from 30. So W is a. 5 root 3 over 2. Yeah, so then x is across from 60. 60 is the a root 3 side. So if we need a root 3, then we're going to have 5 root 3 over 2 times root 3. So if this is the a side, then the a root 3 side would be a root 3. You can put a 1 on the bottom if that makes it easier for you to multiply. Yeah. So this is the a side, this is the a root 3 side. See that? A root 3. So when we multiply that, wait, it's root 9 though. So 5 times root 9 is 5 times 3. What's 5 times 3? Okay, so a root 3 is 15 over 2. So x is 15 over 2. Okay, so that wasn't so bad. I'm not gonna lie, I kind of like these puzzles. I think they're fun. I don't know, I thought it was kind of fun. Zoom out, I say zoom out. Alright, how are your brains feeling? So see how this was a? The other times we've done a and then we had to find the 2a side. This time we had the a side and then we had to find the a root 3 side. So since we went from a to a root 3, I went a and then I multiplied by root 3. I went a and then I multiplied by root 3, see? a root 3, a root 3.
Did we have to write the word problem?
No, just say, maybe just say word problem. Yeah. Does that help if I write x equals? Okay. Yeah, x was the a root 3 side, so we just took our a, we multiplied by root 3. Okay, I don't know how to say, breast is what I keep saying, but then you guys, your faces act like I'm saying breast, which I'm not. So, Bruce. Bruce.
Mr. Algebra.
Just say that.
Algebros. All right. Mr. Kelly called Mr. B over to his house to move a box up some stairs to his second floor, like he saw how to do on The Big Bang Theory using math. Well, now I want to know.
I think we have to watch this now.
Let's just stop and start watching.
When they were finished, they wanted to see how far they moved it. They measured along the floor and realized the longer leg was 12 feet long. How far did they move it? Well, how do we even know it's a 30, 60, 90 triangle?
We don't assume in math.
You don't.
So we just can't.
Okay, that's fine. Well, yeah, there's not enough information. Okay, let's see how you guys feel about this one. This one feels wrong somehow. It feels wrong. Doesn't it feel wrong? Math problem, why you do that to us? Math problem, why? Why you do this? Math problem, why? Yes.
Yeah, x is just 9, right?
Why are you guys yelling out the punchline of the problem? That was rude. What if we hadn't figured it out yet?
So embarrassing. I know. Yeah. Looking at the ground. Now that did you check it this morning? So you're still logged in? No, I just. No, but don't you lost it? Oh, you never have. It's not I've never heard of this. Never. You focus on it. No, it looks like what? I should have said it was hard.
Yeah, we should have said that we're like.
Oh, I did it wrong. I did it wrong. I didn't draw it right. It's gonna be a really weird right angle.
Yeah, me too.
I tried so hard. But I didn't do it right. I know that. Oh man, this is really not working out in my favor.
It's not entirely drawn to scale. I tried.
Mine's like really scale. Mine looks like a diamond.
I'm too small. I don't have to worry about being small.
Wait, so 5 is
Yeah.
and y is the hypotenuse.
What?
That's 2A. Hypotenuse? Guys, look at mine.
No, y is, oh, this one, okay. Y equals, oh, y is A on the other one.
That's easy. That's easy. That's really easy.
Whoa, whoa! Don't ruin the punchline.
I don't even know there's a punch. You ruined the punchline.
Whoa, whoa.
That is a goal. It's to ruin everyone's fun.
Well, you can do great at that.
Wait, isn't it? Wait.
What a fun day this has been.
And I'm ready for it to be.
No, wait, I just passed it.
And it's only 9
But it was
seconds.
16.
I found all the stuff.
Dude, why can't I remember which sides go where? Like, that's sad.
Well, it's only going to get harder tomorrow when we have another triangle.
I don't like triangles.
No, actually.
Wait, I
Triangles.
have to
I was talking to my cousin. We're talking about triangles. And there's a microbiology class, and they make babies. We make babies. Did you see the one I posted on my story? Yeah. She make school? What? She goes, she was in Norway.
My baby was a model.
All right. When you are done with your notes, because this is the last problem, then go ahead and start the assignment. All of it. I mean, yeah, I just think, I assume we're doing all of it. I don't know. I'll let you guys know if we need to shorten it.
Except there's no pretty one.
Do everything that's labeled as 7.2.